Hello my fellow friends, welcome back to my channel. This time we are going to talk about end-to-end development of a NLP based tool which is going to detect the language for given sentence. Either you are a beginner in NLP or you are at the advanced stage, this video is going to be helpful. After completing this video, you will not only understand the fundamentals of NLP like TF-IDF, Vectorization or word vector conversions, but also how to build a complete pipeline only with Jupyter Notebook, save your model as a Pickle file and run the inference, or create a live website with the model running on background. And guys, it's a big request to you to please subscribe this channel because creating up this 1 hour, 2 hour long free contents consumes a lot of amount of my time. So if you like to support this effort and want me to come up with new content like this, don't forget to press the subscribe button, guys. So now, without wasting any single moment of time, let's start. Now guys, before we start, I want to make sure that you won't face any error because of the environments. Because I have seen you asking many questions on my comment section saying that I'm having that environment issue, this environment issue. So what I have done, I have uploaded this complete environment list on the GitHub link, and I have provided the link in the description for both this environment and the dataset I'm going to use. So directly go to the description and download the dataset, and if you face any errors, go to this GitHub link and you will get this file over there. Just check that the environment that I am using right now is having the similar package with your environment if you are having any type of environment related issues. Going ahead, we are going to talk about the dataset with us and how we are going to utilize that dataset. Now guys, before we jump into our Jupyter notebook and start the coding, let's have a look on the dataset that we have just now downloaded. So it's a language detection dataset, and you have text on one column and on the other column you have the language name. This is a pretty good dataset because you have every single sentence, I think this is coming from Twitter, is also labeled for that language. And if you scroll down with this dataset, you will figure out that it has Spanish, it has Dutch, it has French, it has Malayalam, it has Portugali, it has Kannada, and many other languages, I think Hindi also. So around 7 or 8 languages are there within this dataset, and we are going to use this dataset to create or to train up the model. So here we are on our Jupyter notebook. I'm going to import some basic libraries like string because this dataset is not clean. We have to do a lot of cleaning step by step, and these are some basic fundamental steps when you need to follow whenever you are going ahead on a project based on NLP. And these are very foundational concept like cleaning up stop words and all, and I'll show you how you can do it with simple code. So guys, let's import some basic libraries which are required for any NLP project. So let's import string. Now pandas, numpy, and we'll need re, then we need to plot also, so we'll need matplotlib, and we'll need seaborn also. So let's import these libraries. Based on need, we will keep on importing other libraries. So I'm going to run this. So first of all, we'll start reading up this dataset. And since I have already saved this dataset within the same folder, so I do not have to copy path and all. So let's import language detection.csv. So guys, let's save this dataset. df is equal to this and print the head of this dataset. So here is our dataset. As you can see, we have text and languages, but this data is not very clean. As you can see, we have commas, we have double colons, we have dots, we have brackets, a lot of information which is not necessary. I'll say we should clean it out. For cleaning up the dataset, either we can write up our own function or we can utilize the Python provided punctuations function, which is a module within the string library. So if you look out this string library, let me just go down here. If you write P and then press tab, you will get this punctuations. And let's run this. So this command will give you all type of punctuations. Now you have to remove these punctuations from this text folder. And also, since we have some words which are on the uppercase, some which are on the lowercase, let's make all of them in lowercase. So I'm going to do both the tasks in a simple function because after having a function, we can actually use that function and apply this on top of this data frame. In that way, it will save a lot of our time. So let's write up a function named as remove pun. Now this takes up some text, so let's write text. We will write up a for loop and we will iterate to all these punctuation words. So I'll write from string dot punctuations, punctuation not s, sorry. So we'll have for pun in this here. So we'll use the remove command. So if I write my name is J and I want to remove all J out of this line, so I can write replace and I can write J over here and then I'm going to replace it with nothing. So let's run this and you can see the J is removed from the string. The same method will apply on this text coming out within this for loop. So we will write replace here, and since it is iterating on this pun is actually iterating, so we'll write pun to this double colon. Then we also need to save it, so we'll save it inside text only. So I'll write text equal to text.replace pun double colon. Now we also want to make that text lowercase, so after the removal I can write text is equal to text dot lower. So it is going to completely lower down the caps or the uppercase letters, and this we are going to return now. Okay, txt. Now this is our function. Now let's apply this function on top of some strings which is coming over here. So as you can see, nature can refer something like something. So I'm going to write down this over here and let's do this. Now I'm going to pass this complete string to this function and look that this function is working correctly or not. Let's put some other punctuation also, like double colon and then this. Now we will apply this function remove pun. Wow, so as you can see, all this exclamatory mark, double colon, everything is gone and this function is working pretty well. Now the benefit of having a function on hand is that I can actually apply this complete function on top of this data frame. So let's apply it and see it's working fine or not. So we can write df dot, or we can write vdf text write down this function name and let's see. So as you can see, everything is working fine. We have been able to apply this function. Now let's save this new values. And here is our data frame with somewhat cleaned data. So guys, we have done some basic cleaning on top of our dataset. This is the time to divide our dataset into training and testing splits. We will be using the train test split provided by sklearn library to do the split over here. So let's import the train test split from sklearn. But before we apply the train test split on top of this data frame, we actually need to have our x and y as in separate values. So we will use the ilog command. So since our text, which is the x values, is in the 0th column, so we'll take all rows and 0th column over here, and in the y's we will take all rows and the first column. Let's save this within x and this within y. Let me print this x also. So as you can see, here we have all the x coming out as in single series, and you have y also, which is having all the languages. So this is good. Now we will apply this train test split function on top of this x and y. So we have to give x over here, we have to give y over here, then we can give how much percentage of the total dataset we want to keep in the testing side. And here you can give around 0.2. So this should be caps y. This actually returns you 4 values. The first one will be x train, then the second one will be x test, then y train, then y test. So let's save this within variables, comma y train, comma y test. I should have this also in caps. Now these are 4 values of x, y, and actually I can print them and we will just clarify that our values are coming correctly or not. So you can see we have x, and here on the index side you can see the first index is 1526. So it means the values are randomly selected. So this function is very good. You can use it in any type of algos. So guys, we have splitted our data set into training and testing part. But there is something missing over here. Our model cannot absorb these string values. I cannot feed this complete sentence to our model and tell and ask model to do some calculation on top of this. So there comes the use of vectorization, or converting these strings into some feature or some numerical value which my model can understand. And there are n number of ways to do so. I'm going to talk about Unigram, Bigrams and TF-IDF technique over here. Before we get into the actual coding, let's understand how the techniques actually works on the background. So let's understand this with an example. I have a sentence saying that I am happy. Okay. Now if I want to convert this I am happy to a vector, what can I do? So the best thing I can do that, I can just figure out how many unique words are appearing within this sentence. So I have I have am, I have happy. Then I can give these as in unique features, like I am happy. So I will have one feature named as I, the other one is am, the third one is happy. And I can count how many times they are appearing. But in case of NLP, we usually say them as in document. So we can say small t1. And in that way you will have other sentences also, like document 2, which is saying I am unhappy. If I have these two sentences, I can see that I and am are unique for both the sentences. The next thing that I can take is unhappy. Now I'll have 4 features in my vector. and I can actually count how many times these features are appearing within my documents. Like for D1, I is appearing one time, M is appearing one time, and happy is appearing one time. But unhappy is not there, so we'll write 0. So this is a vector, and this is for D1, the first sentence or document. Now if for D2, I have I, M, but happy is not there, so I'll write 0, and then we have unhappy. Okay, simple. So right now we are taking individual words into consideration. So if I say this sentence, I am happy, and if I say, am I happy? Now these both sentences are completely different, but what is happening over here? I'm getting the same sort of vector out for both the sentences. So in some way, we are losing some sense of continuity over here, or the relation between two words. So this techniques where we take only one word is called Unigram. Okay? If you want to consider the connection between the words, we can go into bigrams. Now what is bigram? In bigram, we take I am as in one feature, then am happy as in second feature. Okay? In the second one, the view will have am unhappy. Sorry for. So you are taking two words into consideration. That's why it is called bigrams. Now if you see, you can go even for trigrams. There you are taking three words in continuity as a single feature. So I am happy itself becomes a feature out there. This is the story behind unigram, bigram, and trigrams. In the case of model training, you can actually take all three into consideration, where you are having your unigrams as well as your bigrams as well as your trigrams. So these all will become features for one document. And in this way, you can have multiple documents. As we have a big data frame, all the sentences are called individual document. You figure out the unique words out there, then you create up this sort of vector form where you have how many times the word is appearing within the sentence. So this guys have some issues again. There will be many words in a language which are very frequent. Like we say in these two sentences, if I want to see there is some difference between the two sentences, unhappy and happy words are giving the most sense out over here. If I see the I am words over here, they're not making any difference between the two sentences. But happy and unhappy are the words which are making a lot of difference over here. So why not give higher weightage to happy and unhappy and give lower weightage for I am? So there comes the TF-IDF technique. So TF is the term frequency within a single sentence or a document. Let me clean this out so that we can do it. So we have the sentence now, I am happy, and other one, I am unhappy. Now in these two sentences, let me write this as document 1 and document 2. If I see, so what will be the term frequency over here? So term frequency for D1, if I see for I, it will be 1 divided by the total number of words. So I have 3 words, so it will be 1 by 3. For M, it will be same 1 by 3. For happy, it will be same 1 by 3. And that goes with the D2. You will have, so why I am doing divide by 3, I want to take into a calculation sort of which is ranging between 0 to 1. That's why I'm just dividing it the total number of words within document. Now what is IDF? So IDF is the inverse document frequency. So if I see, so the IDF for I will be how many times I is appearing both of the sentences. So the total number of sentences or documents will come into the denominator, and how many times I is appearing over there will come into the numerator. And you just have to take the log of this value. Okay, so log of 1 will be 0. Now if you multiply this TF and IDF of this I will have 1 by 3 multiplied by 0, which will make this complete TF multiplied by IDF 0 for this. But in case of unhappy, I will have, since we have two documents, so I will have 2 in the denominator, but I will have 1 in the numerator because it is only appearing in the first sentence. So the total value will be log of 0.5. That will give you some value. Once you'll apply this to this value, once you'll multiply this to this happy value over here, you will get some value out over here, which will not be 0. So in this case, you are giving the higher weightage for the words which are appearing least in the document and having the higher impact. So this is the concept behind the Unigrams, Bigrams, Trigrams and the TF-IDF. Now we will write up the code to figure out or create a vector matrix out for our document, feed it to a model to train up on top of them. So now we understood the theory behind TF-IDF. Now let's vectorize this dataset and create the features. So as long as it sounds in the theory side, it's very simple to code it out because we have a library available from sklearn. From sklearn import feature extraction. Now with this library we can actually create a vectorizer. I'll cite vec is equal to feature extraction dot text dot. So we have TF-IDF transformer vectorizer, so we have to use the vectorizer over here. So over here you have to give the n-gram range. So n-gram range, as I told earlier, we have Unigram, Bigram, Trigrams. So we are giving, if I give 1, 1 over here, it is going to take the Unigrams. If I'm going to give 1, 2, then it will take Unigrams and Bigrams. So for now, let's take 1, 2, and here we have to give the analyzer. That will be char. As like other sklearn models, we cannot directly go ahead and train up our model here. So we will be using something called as pipeline. So I'm going to import this pipeline from sklearn, and then we are going to define this pipeline. So pipeline is something like if you want to do some sort of continuous work where you are first converting your text to a vector and then also training it out, you can create up pipelines. So it's kind of creating up a complete flow of functions. So for doing the pipeline thing, we have to just write pipeline.pipeline, and inside bracket we have to define what all tasks we want to do. We want to apply the vectorizer, so I'm going to write vec, vectorizer. This is the same vectorizer that we have defined over here. Once this terms gets vectorized, we want to apply a model on top of this. For now, I'm using the logistic regression. You can apply other models like LGBoost, random forest, or simple decision trees, whatever you want. So we have to give a name for that pipeline component. So I'm going to write CLF. Actually, we have to import the model first. So I'm going to use this linear model from sklearn, which have logistic regression model. You can just select this logistic regression bracket. This all pipeline components you have to write within a square bracket. So this is something like a list form you need to write. So once you will run this, you will see that it has created up a pipeline which have multiple steps. In the first step, it is going to take up your string, convert it into a vector form, then it is going to train up the model. Once you have defined your pipeline, it's very simple to train up your model now. So let's save this pipeline component within a variable. I'll say model pipe, model pipe. Oh, I should have had some better name, but no issues. So dot fit. So it is It is the same way how we actually fit up the models for other sklearn methods. So here you need to give the train component. So I'm going to give the X train and Y train. And let's run this. So once you will run this, now on the background it is converting the complete dataset into vector form and training up your model. So this is all. Now our model is trained and you can actually see your model components over here. So you can see like classes. So you have these many languages over in that Y variable, like Arabic, Danish, Dutch, English, French. All these languages are there in that data set. Now let's try to analyze this model and see how accurate it performs on the testing dataset. We will apply the predict method and we'll give the X test over here. So this is going to predict the Y values for all the words which are in the testing dataset. And here is the predicted one. So I'll save it within a predicted variable. Predict well. So this is our variable which contains the predicted labels. Now this is the time. Let's calculate the accuracy. So sklearn have this matrices which can actually give you the accuracy of the predictions. So within the matrices you can actually apply this accuracy score, and this one you can give the actuals versus predicted. So I will just check. It takes Y true and Y predicted. So these are the predicted values and you have your Y test. These are the actual values. So here it comes, we got 97% accuracy. Let's multiply this by 100. Yep. So we have this 97% accuracy coming out with this trained model. Now you can actually see how the confusion matrix looks like. So within the matrices itself, you have confusion matrix which actually takes up the same arguments. And here it comes. So guys, here you can see the confusion matrix is coming pretty well. You can use Seaborn to create a better visualization, but now my focus is not that. I want to test my model for multiple languages by giving a string on time. So let's do that. So I will take this model pipe over here, this one, and let's go to the next cell and we'll use the predict method. And let's give some words in English. So I'm saying my name HJ. Okay, let's run this. Okay, I think I have to put up a bracket. Now let's run this. And you can see it's predicting pretty well. The English word is coming pretty well over here, and put it over here. Okay, now it should give the Hindi word on top of, it should give the Hindi language. Let's see. Awesome. So you can see it is able to detect the language pretty well. So guys, again, before we go ahead and create the web app out of this application, please subscribe this channel, because that gives me a lot of support to create such videos for you guys. Okay, we are good. So now we have to save this model as a Pickle file, because we want to use this model on our inference and we also want to create a web app out of it. So in the next part, let's import the Pickle library. Open up a file. I'm writing new file is equal to open. We'll say model.pkl. Going to write this file, so we'll open it in WB mode. This command will open up a file in the current folder where your Jupyter notebook is right now running. Now within this file, you need to dump your model. So we will use pickle.dump. And if you see, you can dump any of the Python object within the Pickle file. So you have to give the object name, then the file name. So we have our model saved as in model pipe. So let's save this over here, and then we need to give this new file. Now this is going to dump your model into this Pickle file. At the final, we have to close this file. So I'll just write close. And you can see this file is now closed, and you should have your model ready in the folder where you are running this Jupyter notebook. I can actually check that. I can do OS, import OS, and I can do OS, or I can just do like ls over here. Oh, it's not running. And I can do os.listdir. And here you can see model.pickle file is now saved. Your model is now wrapped and saved as a pickle file in the current folder. So we will use this file again to run the website. If you go to our Jupyter notebook, the format should be pckl. I haven't checked it with pkl format, but I think that's a small mistake. You can correct it and run it again. So now you will have this model.pckl saved within the same folder. So if you see the app.py, so this is the app.py that we have created, and if you see, it's a very small file, and this is the file which is creating up that complete web interface. Now I'm importing some of the basic libraries, Streamlit web browser and all, and then I am having this global variable defined at the start, and within this global variable I'm actually opening up that pickle file, and then we are loading up the model from that file, and we are just closing that file. And here, if you see, this is the way how we write code within the Streamlit, and you have this st.title which will give the title for that web page. And after that you have an input text box, and here you have to give the text input. So user can give the text input within that text box. So you can have some default values given to that box, and you can have some description for that box. So here I'm writing up the description, that is provide your text input over here. And then we have the default value that hello, my name is Jay, that is the default value within that app. Then we are creating up a button by which you will click that button and it will throw out the model output. And what it is doing, that all the input given by the user will be saved within this input text variable. And then we are passing out this input text variable within this simple command. And here we are using the model.predict command, and we are passing out that text forwarded from the user side. And this will give the predicted label for that input text. Now, all in all, we are good with this app.py. Make sure that you have installed Streamlit before moving ahead. And once you have installed Streamlit, it's very straightforward. I can actually go back over here. I can go to the terminal here. So once you will be in this terminal, you need to do Streamlit run app.py. So as you can see, I have just given Streamlit run app.py. So right now I am doing this : because this is saved within that folder. But if you are in the same folder, you do not have to worry about that also. So this will open up this host, and if you go, and this will open up a URL again. And if you go over here, this is the text box where the person can give input. And once he will click on this get language name button, he will get the name of the language. So we have Turkish also, we have some other language also. You can test out it. I can do one with Tamil language. No, spelling is, yep, correct. Now if you go down, if something is written, okay, we have this written over here. Let's put this Tamil over here and run this. So you can see it is able to predict the language name for Tamil. So see guys, you can check out this tool. So see guys, no tool is usable until and unless a user can use it. So usability of machine learning model is something which is in quite limelight right now. And if you are, we can actually, in couple of my future lecture, I will tell you how to create a packaged version for your machine learning app like creating up a Dockerized version and then deploying it on a AWS or GCP servers. So for now, this is all guys. I hope you have liked the video. If you are first time visiting to my channel, don't forget to press like, share and subscribe button.